Welcome to example 3. We have an example of mineral samples that are being pulled up through a mine shaft, and this is a nylon rope. Down on the bottom here we have a 20 kilogram mass that has been being hoisted upwards, and there's a geologist down here at the bottom, and what we're looking for is what is the speed of the wave. So if this geologist were to send a wave pulse up here, how fast would this wave be moving upwards? So let's start off by determining the tension that is pulling down on the nylon rope. So for part A, let's find out that tension. Now that tension would be equal to the weight that is pulling downwards, which is mg. Our mass is 20 kilograms, and the acceleration due to gravity is 9.8 meters per second squared. So that gives us a tension of 196 newtons. So the reason why we want to get the tension is we're trying to determine the wave speed. And the wave speed earlier we found was equal to the tension divided by the linear density, which is m over L. That's the amount of mass per unit length. Okay, so let's sub that in here. Our tension is 196 newtons, and we're dividing it by the mass per unit length. That's the mass of the rope, which is 2 kilograms, divided by the length of the rope, which is, well, looks like it's 80 meters because that's the depth of the shaft. So that's 80 meters. And so if we substitute that into our equation here, we'll get a speed of 88.5 meters per second. Okay, so that's part A. Now part B is asking if a point on the rope is given a transverse wave, which is going to follow like simple harmonic motion, like a sine wave going all the way up here. And the frequency was 20 hertz. That means he's moving it up side to side 20 times per second. We want to know what would be the wavelength of this wave here. Okay, and that goes back to our wave equation. V equals F times lambda, and we're looking for the wavelength, so that would be the speed divided by the frequency, and the speed of that wave is 88.5 meters per second, and the frequency would be 20 hertz, and this will give us a wavelength of 4.43 meters. And that's it for example number 3.